MATH5130 transitioning from confidence intervals for proportions to something that we'll encounter a lot more, and that's confidence intervals for means. Again, transitioning from describing sample data to using our sample data to make a statement about a larger population. So first step, frame your research question. In the previous couple of videos, we've concentrated on confidence intervals for percentages or proportions. Now we're going to transition into calculating confidence intervals for means. So let's say that we would like to know the mean glucose level for those living in a small Appalachian town. We can assume this town is, has quite a few people in it. There's no way to go out and take the glucose level of every single person. So we take a random sample. So again, take a random sample, measure the glucose levels, statistically describe the sample with means and medians. Let's just say, again, fictional example here, that we've, again, taken a sample of 200 residents, and we observed a mean glucose level of 117.2 with a standard deviation of 8.5. So I'll tell you what, I want to write that down, so give me just a second. All right, and N is 200. Okay, so proceeding as we did before, we'll now generalize. So we do that using a confidence interval. I've already gone ahead and calculated the 95% confidence interval. It's 116.01 to 118.39. Again, not to be redundant, but to be redundant, we calculate a confidence interval using the point estimate plus or minus the critical value times the standard error. The point estimate here is 117.2 because that's the mean that we got from our 200 randomly selected residents. The critical value is 1.97. Notice it's not 95% anymore. We use a different underlying probability distribution. And again, guys, I don't have time to go into all that. I'm trying to teach you to think like a nursing researcher. And I'm not trying to teach you to be a statistician. Just trying to teach you to use statistics to make a statement and add to knowledge in your discipline. And the standard error here turns out to be 0.601. Now, just like I did in the previous example, I'll upload a video after this one diving into the weeds a little bit more using R and StatCrunch. So not leaving you hanging, just want to try to get a presentation of 95% confidence intervals for means in this video. All right, so again, plug the numbers in, add, subtract. You notice that 111 or 118.38 is slightly off from 118.39. This is simply due to rounding. Margin of error, just like before, you take the big number minus the small number, divided by 2. So that doesn't seem 116. Okay, yeah. So the margin of error in this case would be plus or minus 1.19, not 1.19%. We're no longer doing percentage problems. We're doing mean problems here, focusing on mean problems. So the margin of error is just 1.19. Sorry, losing my voice all of a sudden. Critical values, again, if you want to learn a lot more about critical values for these types of confidence intervals, you can Google that and learn more in your textbook. I don't think we need to in a class of this nature. But just remember the critical values use the t-distribution instead of the z-distribution, and our t critical value is calculated on what we call the degrees of freedom, our sample size minus 1, and not the standard normal distribution for the confidence intervals for proportions. If you want to forget everything I just said over the last minute, I'm okay with that. Interpreting a confidence interval, correct and incorrect interpretations are the same. So the correct interpretation, there's a 0.95 probability, or We are 95% confident that this interval contains the true value of the population mean mu. Again, what does the population mean in this context? It would be the glucose level for all residents in this particular, I think it was a small Appalachian town. I believe so. Stat Crunch, really easy to find. Go to stat, but instead of going to proportion stat, you go to what's called t-stat. Technically, what we're calculating here is called a t interval. So go to t-stat, go over to one sample, go to summary, enter the data, 117.2, 8.5 is the sample standard deviation, sample size is 200, click the confidence interval for mu, make sure it's set at 0.95, which it will be, hit compute, and you'll see that you get the sample mean standard error. Notice the DF, the degrees of freedom, 200 minus 1 is 199, and we get the lower limit and upper limit of the confidence interval as calculated before. Okay, next video I'll demonstrate more about this in R and StatCrunch. All right, take care.